Let me explain this example. The length of a human pregnancy is normally distributed with a mean of 272 days with a standard deviation of 9 days. First, let me check the given information. Normally distributed, mean 272, standard deviation 9. Part A. Identify the random variable. What is the random variable here? We talk about the length of a human pregnancy. Therefore, we can define a random variable y as the length of a human pregnancy. Now, let me translate the given information into a mathematical statement. Here, y has normal distribution with mean 272, the standard deviation 9. Okay, now go to the part B. Calculate the probability of a pregnancy lasting at least 280 days. First, translate the statement into a mathematical statement. At least, therefore, P probability y greater than or equal to 280. Now, what is the first step? Step to find the probability of y greater than or equal to 280. We need to convert to the z, right? How do we convert to the z? Using y minus mu over sigma. So we need to find the corresponding z value of 280. Therefore, y is 280, mu is 272, sigma is 9. So corresponding z value is 0.889. Here I calculate a z value for the 3 decimal places. Then I round to the 2 decimal places. Then I continue with the 2 decimal places. Right. Now we know probability of y greater than or equal to 280 is equal to the probability of z greater than or equal 0.89. Now can we use the z table? Not yet, because we have greater than or equal here. Therefore, we need to convert this to the less than or equal. How do we do that? Whenever we have a z greater than or equal, we write 1 minus probability of z less than or equal 0.89. Now check the two conditions. One, z value. Yes, we do have z value. Second one, less than or equal. Yes, we do have. Both conditions are satisfied. Therefore, we can go to the z table, find the corresponding probability of 0.89. That is 0.8133. Then we subtract from 1. The answer is 0.1867. So we can say the probability of a pregnancy lasting at least 280 days is 0.1867. Now go to the part B. Calculate the probability that a pregnancy will last at most 250 days. Again, let me translate the statement into a mathematical statement. So at most, that means probability P y less than or equal 250. How do we find the probability of this y less than or equal 250? First, convert to the z. How do we convert to the z? Using y minus mu over sigma. Here y is 250, mu is 272, sigma is 9. Therefore, corresponding z value of 250 is negative 2.44. That is the rounded number to the 2 decimal places. Now you see both conditions are satisfied. We have z and the less than or equal. Both conditions are satisfied. Then use the z table. Find the corresponding probability of negative 2.44, that is 0.0073. Therefore, the answer is 0.0073. That is the probability that a pregnancy will last at most 250 days. Right. Then go to the part D. How likely is it that a pregnancy will last between 265 and 290 days? Again, let me translate the statement into a mathematical statement. It is probability of y between 265 and 290. Then how do we find this? We have to find the z value for these two numbers, 265 and 290, using y minus mu over sigma formula. So first one, y value is 265, the second one, y value is 290. So z values are negative 0.78 and 2 respectively. Now we can write using the z, probability of z between negative 0.78 and 2. Right, what is the next step? Whenever you have we need to find the probability between two numbers, we split this. How do we do that? We separate this like that. First with the big number, then the small number. You know here big number is 2, so we write down probability z less than 2 minus always probability z less than small number, that is negative 0.78. Here always we use less than or less than or equal because this the continuous random variable, normal distribution is continuous, and we have z values. So both conditions are satisfied. Now we can go to the z table to find the first one, probability of z less than 2. So go to the table, probability is 0.9772 for the z less than or equal to, or z less than 2. Yes, so 0.9772. Then we need to find the probability of z less than negative 0.78. Again go to the table, negative 0.78, that is 0.2177. So you can subtract from the previous one, then answer is 0.7595. So we can say 75.95% of all pregnancies will last between 265 and 290 days. Go to the part E. Find the length of pregnancy that 10% of all pregnancies last less than, right? Right. How do we do that? Yes, here the problem asks you to find y value here, y value from the probability, right? So here it says 10% of all pregnancies last less than, right? So first let me draw the density curve. This density curve is symmetric around 272 because 272 is the mean, right? Asking the 10% of all pregnancy, right? 10% mean the area from the left corner. So asking the y value that has 10% of the area from the left corner. That means this. Okay, actually you know the 10% from the left corner, that is the 10th percentile. So we can write P10. Okay, how do we find the 10th percentile then? That means P10. Yes, we can use the table because we know the less than area or area left of P10. Go to the table and check for the point 1000. Yes, we know point 1000 must be in between these two numbers. Which one is the closest? Point 1003. So find the corresponding z value, that is negative 1.28. Right. Now what is the next step? Yes, we have the z value, corresponding z value for the 10% from the table. Now we can convert P10 to the z value using the formula y minus mu over sigma. So here y is P10. So the z value of P10 is this. P10 minus 272 divided by 9. Now we know these two z values. That means the z value from the table and the z value from the formula must be the same. Therefore, make them equal and solve for the P10. So P10 is 260.48. So that is the answer for this part E. Now go to the last part. Suppose you meet a woman who says she was pregnant for less than 250 days. Would this be unusual, and what might you think? Yes, could you remember we had a answer in the part C? So it's related to part C. So let me explain. From part C, you found the probability that a pregnancy lasts less than 250 days is 0.73%. Actually, since this is less than 5%, it is very unusual. Yes, if you have probability less than 5%, we can say it is very unusual.